Okay guys, I'm just going to finish up here from lesson 10.6, and we were talking about angles that intersect, or secant or tangent lines that intersect on the outside of a circle. And to find those, we're going to take 1/2 the difference of the intercepted arcs. So in this case, we want to find the measure of angle CD, which is this guy right here. Or sorry, the measure of arc CD. And we have the other arc that's related to the given angle A here. So I'm just going to set up a little equation. The measure of angle A, which is the intersection on the outside of the circle, is equal to 1/2 the difference of the intercepted arcs, which is, to get a positive difference, is going to be the large arc, CD, minus the smaller arc that's created, which is the measure of arc BC. And then I'm just going to fill in what I have. I actually have the measure of angle A is 56 degrees. The measure of arc CD is the thing that I want to find. I'll put a little question mark there. And the measure of arc BC is 95. I am actually going to get rid of the 1/2 first by multiplying both sides by 2. And that's 112 degrees is equal to, and our 1/2 is gone, the measure of arc CD minus 95 degrees. Then we're going to add 95. And that's going to give me the measure of arc CD, which is what I wanted to find, is equal to 207 degrees. For the last example, example 4, it's an application problem. It's really the same thing. It's just giving us a picture here. It says the diagram shows the path of a light ray as it hits a drop of water. The ray is bent or refracted at points A, B, and C. And then it gives us some measurements. It says if the measure of arc AC, so here's arc AC, is 128 degrees, and the measure of arc XB or XBY, which is this little guy, is 84 degrees, we want to find the measure of angle D. So this is really the same problem, they just put it in application form. The measure of the intersection on the outside, which is angle D, is equal to 1/2 the difference of the arcs it's created. So the measure of arc AC minus the measure of arc XBY. The measure of D is what we don't know, so that's what we're trying to find. The measure of angle AC is 128 degrees. The measure of angle XBY is 84 degrees. So I have 128 minus 84 is 44. And then half of that, which is 22 degrees. So the measure of angle D is 22 degrees. The last part of the notes is just a table that kind of goes over the different things that we talked about. And this first one, it has vertex on the circle, so different scenarios. That was really our inscribed angle. Which we know the inscribed angle is half the measure of the intercepted arc. We just wrote it a little bit differently by putting X as our intercepted arc there. Then we have an intersection on the inside of a circle. And when that happens, we are going to take the measure of the angle created there by the intersection is half the sum of the intercepted arcs. And when we have an intersection on the outside of the circle, then the measure of the angle is equal to 1/2 the difference of the intercepted arc. So it looks the same, but inside intersection, which kind of looks like a plus sign here, you can see my plus sign. Some people say it's an X. We have to get a little creative with the idea that it's a plus sign, but definitely looks more so than intersection on the outside of the circle. So there you add the arcs, and then on the outside you subtract the arcs. All right, you have an assignment. It's page 746, numbers 8 through 26. Be evens.